Okay, so these are very broad general steps in problem solving that apply both to chemistry and the real world, actually. First thing you need to do is identify what you know. What are your assets? It doesn't matter if we're solving a problem in chemistry or you're solving a problem in the real world. Okay, some things come up. Oh, I need to move. Okay, so what we know? Well, I've got to move from here to Tucson and I got to be there by this date, blah, 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 blah. All right, I'm not moving to Tucson, although I might want to, I don't know. All right, but anyway, all right, and then the second step is always to identify what you want to know, all right? And you need to be as specific as possible, all right? And then define the relationship. How am I going to get from what I have to what I want to have? And once you kind of get that relationship, then you set up all the details and solve it, all right? So go ahead and write those 4 steps down real quick, and I will refer to those as we are doing these problems today. Oh, and while you guys are writing that down, I'm going to hand out some problems that we will work out as our notes. That way you don't have to write down all the information for the problem. Does that make sense? Oh, if I can find them. Dun, dun, dun.
Mr. Beamer?
Yes, sir.
When's the quarter over?
Next Friday. Next Friday. Yep. What's that? That's when, yeah. Well, so technically, I guess it ends Thursday. We have to turn in your grades on Friday. All right. So, yep. Oh, you know what I would be doing though? I would be working on my chemistry during chemistry and not my English during chemistry.
Oh, I'm reading this book for fun.
Yeah, you're not.
Do we have another test before?
We're not gonna. That's what we were trying to see if we could work in a little quick quiz. But I don't think no, your grade won't drop. So yeah, hopefully this will help us out. Yes, sir. For the test. Okay, we'll work on it some today. I'm gonna tell me, and I will get it completed. Yeah, but some of these things, as it comes in, if it doesn't save it, I don't catch it, it kicks it back out, and I don't know why. This computer's stuck. All right, okay, and I'm recording all this, it'll log around saying it's I think the world knows I hate computers. Computers are the devil. I think overall in the world, computers have created more problems than goodness. Wouldn't you say?
I agree.
Yeah. Super fast. Okay. Oh, and there's one already here. Okay. All right. Now, this next slide, you do not need to write these things down, or at least not the full sentences. All right. What we're going to be working on. All right. In general, we're going to be able to go from grams to moles. How many is in a mole? Do you guys remember? Is that a great big number?
3.17.
Nope, not 3.17. I don't know what that is. Great big number. It's Avogadro's number. Something to the real big? Yeah. It's 6.02 times 10 to the 23rd. Remember, that's just our dozen thing. 6.02 times 10 to the 23rd. All right? But we're going to be able to go from grams to moles and moles to grams. We're already over halfway there, actually. We're also going to be able to go from moles to particles. That's the 6.02 times 10 to the 23rd. And vice versa, from particles to moles. All right? And then we're going to be able to put them together and go from grams all the way to particles. The mole becomes my translator. All right? And lastly, and we won't get to this till next week, we're going to be able to go from volumes of a gas to moles of a gas and back and forth. But we're only going to deal with it at STP, standard temperature and pressure, which hardly ever occurs, but it's the standard we go from. In the college class, I used to be able to do it in the high school class, we just don't have time, but in the college class, we go for non-standard conditions as well. All right? Okay, so like I said, you didn't need to write a lot of that down. We're going to be doing these today. This next map, I will eventually post this. Do not copy it down. You don't have time. I'm going to move on. All right? This shows you, like from grams, I can get to moles. From atoms, molecules, or whatever particles, I can get to moles. And from volume, I can get to moles. So the mole becomes our translator. So essentially, I could get from grams to the volume of a gas, or vice versa, volume of gas to grams, or from the volume of gas, like we could calculate how many molecules are in a balloon if we know the size of the balloon, stuff like that, which is kind of cool, actually. All right? So that's what we're going to be doing. Now, we're going to go to the practice problems I just gave you, or actually example problems. All right? So let me slide this over. All right? So we're going to start with the first one. The first one goes along with what I said on the first step there. We are going to read it. I will not force you to, I guess the new word is annotate, but I'm not going to make you do it the way I do. But what we know here, it says convert 185 grams of ammonium sulfide to moles. So what do I know? I know 185 grams of ammonium sulfide. What do I want to know? Moles. Yeah, I want to convert it to moles. And then the next step was to define the relationship. Well, before we can define the relationship, we got to write the formula correctly. If you have your pick sheet out, you might know, but does anybody remember what ammonium is? NH4, very good. Nice job. And NH4 has a +1 charge. Sulfide is just going to be the element sulfur. Okay? What is sulfur's charge? You can look at the big periodic table. -2, very good. So who do I need more of? I got to have more ammonium. Very good. So it's going to be NH4, 2, and then an S. And we put the NH4 in the parentheses. All right. So the relationship between grams and moles is that molar mass that we've been doing. The molar mass, okay? So we got to add that up. Remember I told you when we first started it, it would become a step in bigger problems? This is the bigger problem. Well, this is the mid problem. They get even bigger than these. All right, so how many nitrogens are here? Just 2? How many hydrogens? So it's NH4, 2, so 8. 8, very good, because you got to multiply it. You use that distributive property. All right, and then how many sulfurs? Just 1. And then we look up their masses. I actually know these ones because I've done these a lot. 14, 1, and 32.1. Multiply it out, 28 and 8 and 32.1, and add it all together. 1, 8 plus 8 is 16, plus 2 is 18, carry the 1. So it'd be 68.1. And what was the unit? Do you guys remember? Grams per mole, okay? Grams per mole. Okay, the abbreviation for mole is MOL, and I do the cursive one, but that's not a requirement, all right? So you can just write MOL. You can write it all the way out, too, if you want to. If you're like, why don't we just put the E there? I'm okay with that. Now, this became kind of a point of confusion last hour, so I want to just bypass that and see if we can do it. So what we're saying when we say grams per mole, we're saying 68.1 grams of NH4-2S is equal to 1 mole of NH4-2S. Okay? This will help us when we're setting it up. This is just like last fall when we learned to do some conversions where we said 1 foot equals 12 inches, right? That's an ugly 2. All right? So this becomes a conversion for our problems. So that is the defining the relationship. All right? So what we know, what we want to know, and now we have the relationship. Not yet, no. Now we're ready to set up and solve the problem. All right? All of this just so we can do the problem. Isn't that fun? And you'll get faster at it, guys. You really will. Okay? So we always start with what they gave us in the problem. So 185 grams of NH4-2S. All right? Just like that. Remember doing problems like this last fall? Yes. Okay, cool. All right. Now, if I have grams here, where does it need to go on the next step? Bottom. Very good. I'm glad you guys remembered. We haven't done these problems in a while. And the grams that go on the bottom is from where I added it up. So 68.1 grams of NH4, oops, I forgot the 4, and then parentheses 2S. And what's it equal to? 1 mole NH4 2S goes on top. All right? Whoops, sorry, I made it move. Is everybody with me so far? Okay, now, what this lets me do, remember if the same thing is on top and bottom, I can cancel it out. So I can cancel the grams of NH42S, all right? And that leaves me with moles of NH42S, right? So now I do the math. I multiply everything on the top. If there was more than one thing, I'd multiply it on the bottom and take the top answer divided by the bottom answer. So I'm going to take 185 times 1. What's that going to equal? 185. We can do that one in our head. And then we're going to go 185 divided by 68.1. And we get 2.71, blah, 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 blah. All right. If you write out all those numbers on the quiz, test, whatever, later on, you will lose half a point. All right. How many numbers do I have here? No, right here. 3. So I only need 3 here. 1, 2, 3. What's the next number? Yeah, it's a 6, so we're going to round up. So 2.72. And what's our unit? Moles NH4 2S. Oh, I ran on to the other piece of paper. So the S. There's an S there. All right. Okay. Now, people asked me last hour, and you might ask, do I need to write all of this out every time? You might ask that. Yes, you need to. And the reason why is to get in the habit, because later on, not in this unit, but in the next unit or the unit after that, we're going to be doing multi-step problems where there will be more than one compound we're dealing with, and we need to make sure that we're canceling out the entire compound sometimes. Because in a chemical reaction, like when we're starting with one thing and we want to know how much of the other thing we can make, they will both be in the brackets, and we need to make sure we're not just canceling out the grams, we're canceling out the grams of ammonium sulfide, not the grams of copper sulfide or something like that. Does that make sense? So, is it annoying? A little bit, but you're writing like 5 extra letters, right? That's a first world problem. There are people that don't have a place to sleep tonight, so don't complain about having to write letters. You see what I'm saying? Yeah. All right, now, is this super difficult? Is it? All right. I mean, we've already done all this stuff, right? And we've actually done conversions, but now we're just putting the conversions together with what we're done. All right? Yes, sir.
Did you do 185 divided by 68?
Well, yeah, so technically we did 185 times 1, stayed 185, and then divided it by the 68.1. And then that's our answer, 2.72. All right? Okay? Shh. Hang on. Hang tight, guys. All right, we're going to do one more example, and then we're going to get a little bit of practice time. And then we're going to do the other types, and then we're going to get some practice time. Most likely, we will be finishing this in class tomorrow, okay? It won't be homework today. It'll be finishing class tomorrow. All right? So let's take a look at the second one. All right, what are they giving us to start off with? They're giving us moles this time, right? 2.65 moles of zinc nitrate. And what do we want to find? Grams. So we're going the reverse. We're reversing it. Oh, but what do we got to do first? We got to write the formula? Yeah, we have to have the right formula. Very good. Okay. What's the symbol for zinc? Zn. And what's its charge? Anybody remember? +2. Very good. I heard it over here on my left side. All right. And then nitrate. You guys remember what nitrate is? It's off the pink sheet. NO3. And what's its charge? -1. Very good. So which do I need more of? The NO3. So it's going to be Zn parentheses NO3 parentheses 2. Okay? And then we have to do our formula mass stuff. Everybody feeling pretty comfortable with formula mass? I mean, we've done it on that big sheet. We did it when we had to do percentages. And now, like I said, it just... it just becomes a part of our problem. So how many zincs? 1. How many nitrogens? 2. How many oxygens? 6. Good job, guys. All right. And then zinc is 65.4. Nitrogen's 14.0. Oxygen 16.0. So 65.4, 28.0, and 96. Is that right? Yeah. All right. So then we'll add them. I'm going to do it fast on my calculadora. 28 plus 65.4 equals what? I messed up. Somehow I multiplied in there. 5.4 plus 28 plus 96 equals 189.4. So you guys got? This is a 14. Yep. All right, and that's grams per mole for zinc nitrate. All right, so we got what we know, got what we want, and we got our relationship. Does that make sense? So now we set up and solve. Always start with what they gave us in the problem. What did they give us in the problem?
2.65 moles.
Yep, 2.65 moles zinc nitrate. Okay, if I have moles on top, where's it go on the next step? On the bottom. And the moles for these problems is always going to be 1 mole. 1 mole of zinc nitrate. All right, and on top will be the grams, because that's what I want. I want grams. 189.4 grams of ZnNO3 All right? So what I started with goes on bottom. What I want goes on top. All right? And then what can we cancel? Which unit? The moles of zinc nitrate. All right, we cancel the moles of zinc nitrate. All right, so now we're just going to multiply the top and then divide by 1. If you divide by 1, does it change? Nope. So we're just going to go, oh, I've already got it in there. 189.4 times 2.65 equals. All right, so I get 501.91. How many numbers do I need to keep? 3. So I just go to 502. What's my unit? Grams of zinc nitrate. All right? Is that super difficult? No. Okay, let me pause the video and we're gonna do a couple practice problems and then we'll come back together. Cabbage 5.